Hello everyone. This is Imran for Group B. We are going to demonstrate our project automation application in graphical environment in CAM Studio Works. First, what I do, we are going to do our project in total integration automation portal v11. So what I do, I open the software first and just explain all the aspects of my project. So here it is on the desktop, TIA portal. This is a kind of combinational package of Siemens with WinCC and Step 7. It's an amazing software. It's a latest versions, maybe I heard some kind of new version also available. But here, what I do, just creating a new project in my this software, as I can open my existing software. So what I'm doing now, I'm doing this my automation application in graphical environment. So that is kind of project in which we are going to control three-phase ABB motor with a ABB drive and using the PLC and HMI. So all the programming and interface is being programmed and done in this total integrated automation software. So I'm just going to start this by creating new project. So by clicking this is coming out that what's the project name in here. So here is the project name. I can put any, so that's our group B, so I put it this is it. Okay, now it will open the interface for further steps about this. Okay, so this is the new window where I can start this. Well, first of all, that I will configure some device in here. In this right now it's empty because there is no devices added, and now I will add new device in my project. So here's the list of PLC, HMI, PC systems, which are whatever you want to add. So first I do what is in our project that's on board is our Step 7 300 CPU, that is this one, CPU 314C2 PNDP. I gonna take this one. So this is description of the device in that side, and I double clicked it, so it will just take a time. Okay, so this is our device in here now. We need power supply for this. That's usually 5 amps. So I take a power supply from here for my PLC. That's just right in the window. I take it. That is our power supply. Okay, so this is device overview, in which our device, what is availability in the device, what we can do in this, like addresses, outputs and modules information. For example, in this hour, this is for this PLC which I selected is for digital 24 inputs and digital 16 outputs it has, and analog inputs there are 5 and there are 2 outputs through, and some other informations. Okay, so now I need to add HMI for this, so I have to go back to this add new devices right away, and then it's very easy just to take this from HMI. And what is in HMI list is schematic basic panel, so that is our path. So we have this 4 inches display. Okay, this KP400 basic pin, it's our desired HMI. Okay, I add this HMI in this, and now what I will do this in this way, this just asking us about PLC connection, that while starting is asking about the configuring the PLC connection. So of course I will add this PLC connect with this HMI. Okay, and gonna finish this. So they are connected. Okay, so this is the HMI, how it looks like at the start in this panel. So what I do next, I go to devices network, and I see this connection is done, and in here I can view this topology, this network view. In this network views, like our devices, how it's going to work is like we are going to give them IP address to communicate through Profinet. So in this, like we can get like in real-time project work, we can get the IP address from our HMI, and the our IP address for our system to communicate or to transfer through Profinet. So everything we can done from here, and that is our connections which are done through this. It's not working from here. I guess some kind of problem in here, but well, so next step is to do some kind of programming in our PLC for our project that will make it work. Okay, so I go to this side and I go to PLC tags. Okay, this is no, not really the PLC tags, but first we have to go to this program blocks and go to the main blocks. That's organizational block OB1. That's here. That is what is the main organization block. That's the main manager for our all the sub programs like functions, any kind of other data blocks, function blocks, or else. And now it's quite different than step 7. So like step 7, it has symbolic table. So in here there are PLC tags. So I think I have to go to first in PLC in those tags to add new tags. So I just check. Yes. Okay, so I just remove them, I delete them, they are not our desired. Yes, so in here I can give the names of my inputs, outputs, or the variables whatever I am going to use in my project, and the data type whatever, it's a boolean, it's it's an integer, it's a whatever data types it is. And address, in address we are a little bit confined in case of our project in real time, because we have some kind of information in our PLC that can use only that ways and connections, and we have this ABB drive which is connected to this PLC, that is only our hardware work. So we have connected in on the board, and we have to check that what inputs and outputs we can use, like addresses of all outputs and inputs. It could be in device networks. And in here, if we go to device configuration, then we will know that these our digital inputs, their addresses are like 136 to 138, and output address, they are 136 to 137, and so on. And the same like analog, we have this and this, but it depends, like for example our inputs is input coming from this motor in the form of back EMF, and then is given back to PLC is a analog input. And we have to know that where we can use by checking the channel of the PLC, and knowing the data sheet of ABB drive, so where it's gonna work, where is the motor is going on, high speed or forward, reverse, and whatever. So I go to those tags table. These are all PLC tags. In this, for example, I put this my digital. Okay. Digital mode, that I put here is the memory. Yes, I put here memory 0.1. Then I have digital set. Yes, digital set, same. Then analog mode, analog set, start, stop. It's quite free in this case. We can put any names, and just when the further compiling and in programming, we have to keep in mind that what the names we are using in here, so we have to be careful about them in terms of programming. It could be can't use, for example, same names for input output. That will work, but could be confusing. So here start, we put the start, we put stop. Okay. Well, reverse, forward, and analog forward. Yes. These are all inputs. Forward, I put also this reverse in here. These are all input bits, that could be any we can use. Okay, so while using this PLC tags, we can okay, well, so these my PLC tags are for inputs, and for the I can write some. I just edited a little bit them. Now this motor won't start. I'm using this as the first at this warm start. This motor is just getting ready for running. Well, the address for this is as per our device configuration information, it is Q136.1. so it is, and then our next is motor. Next output tag is motor start. And what I notice is our these addresses, I have to know first what data type is in this case, so I can use proper address. So I have to know what is the data type is in this case. So I just well, in this for the while visiting that data sheet for ABB drive, I got this motor start. That should be like from the truth table of that data sheet. It must be 136.3 address of motor start. And next is motor forward. That I'm just using M for motor forward. Motor forward, and it's using this number 2 according to data sheet. And next is motor speed 1. Motor speed 1. Okay, so that is using number 4. And then I can put this digital it's a bad typing, digital set for that. I put that 2.0 and analog set. Okay, see analog set and 2.1. Okay, so what's most important things while making projects is while doing anything or doing any step in this project, it's better do you save the project uh, time by time. So it's better just to disappoint at the end. For example, if it's a clicked on the cross and you got everything out. So what I do next is I go to it's a good time for programming, and for this I have to go to this program blocks, and I have to click add new blocks, and from here I can add any block, any function block or data block, so whatever I need. So I use function in this. So it's not working. Okay, so that's okay, so already selected, so just clicking one time it's alright. So in this way, so that ladder logic was selected by default. On the right windows we can see in this generates bit logic operations what we need in this this normally open contacts in this ladder logic language, and we can drag down from here also. I just do is maximize this one and just do a couple of branches of programs, and then I just move forward to submit. So in this I take this on normally open contact, and I put this name is to digital mode, that's in here, and for this just maximize it. What I do, I got set, I think it must come in here. Yes, it's here. When on it is on digital mode, this motor warm start, actually this memory output, and it will be set. Yes, it's just when we click on this it comes side. Another method to insert is what we do in this. This is our function block. Okay, anyway, we can work on this further. So what I do, I just make another branch from here, and I set this digital mode. Okay, this is digital mode set, and I just click here, make a further branch, and take another consign. Okay, that's is a wrong one, so I just delete it from here, and that is actually here, that kind of coil, and put here analog. That's analog mode I select. Okay, so in this I forget to put Actually my mouse is not working properly. I don't know. It must come. Okay, it's here. It's going to set this digital mode, and it will reset analog mode. All the working of this digital mode memory 0.6, when it is on, what it will do, it will start motor in its initial position, like ready for running, and in the meanwhile it will set the digital mode and reset the analog mode. And using these branches only mean that the motor will work on only one mode at a time, that's digital or analog either. So, and further we can make further programming through using the same open contact, this digital set, and then using again in the middle this okay start and the end. This resulted the output of this motor start. Oh, that's wrong. Just to be careful. And this is analog, so deleted by clicking wrong way. It's analog mode. Okay. So in here it is motor start, that start in here, and what I'm going to put in here is going to set it. And we can do this with further branching it or doing in each network, but it's quite better we do it in the same. It's quite more professional, and it's easy just to wind up in couple of networks. But how it goes further in that way. And after doing this all the programming, the same thing, I will do the saving project, and now going to this. After doing this all programming for this project in ladder logic, I'll go to this HMI section. That's the most important thing. While downloading, before downloading, I have to compile the program. That's very easy, but just clicking the PLC and compiling compile option, and then it's all compiled while using in the real board. And same compiling option on HMI. So I just click on the HMI, and I will go to screen. Here is the screen option, so root screens, that's it. So this is some tags are default over in here. So my mouse is really bad. This must be selected and must be deleted from this PLC from this root screen. Okay, I got right click, delete. It must select it. Okay, I'm not concerned about those, even if they are deleted or not. but what our next task is just taking these buttons from here. We can simply drag them to there, just like clicking there and just doing this. Also copy this and pasting like here, or click, paste, click and click, paste, click, paste. Okay, so we can edit these text. We can put our desired text on those buttons. So we can change the name in here. I think it's quite easy. Yeah, is for example digital mode. It's also expandable. Okay, that's it. And start. I don't know what's wrong with my mouse. It's actually using my laptop and I don't like it's bad. You know, I have to start, stop, then this speed 1, speed 2, and forward, then another button. Okay, if we can customize these buttons according to our desired situation, we can give them colors. We can put a picture on them. We can do some other properties, changings in this HMI screen root button. So I just gave an overview of this. Okay, so that's it. Just putting in a order, so looking so rough. Okay, that's it. It's a little bit in order. Well, now I just, it's better to save project meanwhile. For example, now this, I go to this button, and in general, these are properties. Okay, this is in this I can set the reset the text, graphics and appearance of this button. I can change the color, background color from here, text color. And so what's the most important thing in here is, for example, when we're using this button for the when this is implementing something, for example giving input to PLC, and for example when we press button from HMI, it works like in fractions of seconds using this falling and rising edges of signal. So what we do, we go to events and we set the buttons set and reset situation. When we press it, then it we have to set, and when we release we have to reset. So we just find the tags from here. Okay, events, go to function, then okay, we can get tags we used somewhere from here. It could be it is set bit. Yes, it is set bit. Now is on set bit, and we can add this tags, this digital mode. Okay, maybe it will find from yes, yeah, it's fine. So that is on the set, and when it's pressed, it's set bit, this digital mode, and when it's released we have to do same. Well, reset, okay, it must be shortcut from somewhere. This is reset bit, and the same our tag is digital mode. That's it. Okay, so that's the way we have to do all our buttons from here, using press, release, and resetting, setting, and finding the tags in here. After doing this, we gonna connect our as using Profinet. When using on the board real-time project, it will be like connected through Profinet. With all our 3 devices will be working, and when we upload this programming, this ladder logic programming to PLC, then it will be recognized the other devices through connections, and some our inputs from HMI, and some inputs from ABB drive, and some outputs PLC to HMI and to ABB drive. It will work digital. It will work on digital mode and analog mode. In analog mode, we will be able to put our desired value, for example the RPMs of motor that it reaches in 40 RPMs directly. So it will be able to do, and that will be possible using some other blocks in OB1, and a little bit more programming using scaling and unscaling blocks. But this digital mode, it will be easy, and by just loading to HMI and PLC and connecting according to datasheet with PLC through the channels and according to datasheet. So that's the brief description of our project. Thank you very much for watching. Goodbye.